So next I am going to discuss some problems based on the motion of the boat in the river, that is boat crossing the river. You see the problem number 7. A boat which has a speed of 5 km per hour in still water crosses a river of width 1 kilometer which is flowing at 3 km per hour. What is the time taken to cross the river along the shortest distance path? So then next question is also related to the same problem. What angle to the water flow the boat must be rowed in order to reach the exactly opposite point on the other bank? So if you want to try the problem yourself, you can take a pause and try this problem yourself first. Otherwise, look at the solution of the problem. The river is given as 3 km per hour and V is given as 5 km per hour. And width of the river is 1 km per hour. Width of the river is noted by D here. V represents the speed of the boat in still water. So it is given that the boat or swimmer moves along the shortest distance path. The problem is given in objective type model in comparative examinations. You can directly use the conclusion I have discussed earlier in case 2. That is the time taken by the boat to cross the river along the minimum distance path is given by T equal D by root of V square minus U square. Can directly use this conclusion in multiple choice questions in comparative examinations. But suppose if you are given similar problem in board examination or intermediate public examination, then you should not use the result directly. You have to derive the result first and then you can use it. Already explained the derivation of the result. That means you have to show the diagram and you should write the description brief. If similar problem is given in board examination, you have to draw the vector diagram. Your Y is the initial position of the boat or swimmer on one bank of the river. A is exactly opposite point on the other bank. So the boat moves along the minimum distance path and reaches the exactly opposite point here on the other bank when the resultant velocity is directed toward the opposite point here. That means the resultant velocity is perpendicular to U bar. The resultant velocity must be perpendicular to U bar. This is the direction of the flow of river water. This is one bank of the river and this is the other bank of the river. Y is the initial position of the boat and A is the exact opposite point at the other bank. So when the boat moves along the minimum distance path, it will reach this opposite point here on the other bank. So then in case you are given this problem for board examination, you must show the working as we have done in case 2 earlier. that V square equal to VR square plus U square. From this you get VR equal to root of V square minus U square. So in this case, actual distance covered by the boat while crossing the river is same as the width of the river. That you can write magnitude of the resultant loss into time. Then you can write this step. But if the problem is given in multiple choice model, you can directly use the conclusion. Here D is 1 kilometer, V is 5 kilometer per hour, and U is 3 kilometer per hour. So you get T equal to 1 by 4 hour. $60 by 4 minutes or 15 minutes is the time taken to cross the river along the minimum distance path. The next question also related to the question number 7. The same question you are asked to find at what angle to the direction of the water flow the boat has to be rowed to reach the opposite point, A on the other bank. That means you are asked to find the angle between V bar and U bar. For that you have to find angle alpha. Here alpha is the angle which V bar makes with the width Y of the river. You can write sin alpha equal to U by V. Here U equal to 3 km per hour and V equal to 5 km per hour. So I get sin alpha equal to 3 by 5. So we use the result sin 37 degrees is equal to 3 by 5. So alpha will be 37 degrees. Therefore the angle theta between V bar and U bar is 90 degrees plus alpha. That is 90 plus 37. That will be equal to 127 degrees. That will be the answer for question number 8. Those who want to copy the solution of the problem, they can take a pause and copy the solution of this problem. Look at the next problem, problem number 9. A man who can swim at 0.5 meter per second in still water crosses a flowing river and reaches the exact opposite point on the other bank by swimming at an angle of 120 degrees with the water flow. The speed of water in meter per second is. You can see the options there. If you want to try the problem yourself first, you can take a pause and try the problem. Otherwise, look at the solution of this problem. See here, in this problem is given that the speed of the man in still water, that means the man can swim with a speed of 0.5 meter per second still water. The speed of the boat or swimmer in still water denoted by V. So that is given to 0.5 meter per second. The figure shows the bed of the river. This is the direction of the flow of river water. Let O be the initial position of the swimmer on one bank of the river. And this is the other bank of the river. It's given that the man swims at an angle of 120 degrees with the direction of the water flow. That means the angle between V bar and U bar is given to be 120 degrees. U bar represents the velocity of the river water. In this problem, you are asked to find the value of U. And it's given that the swimmer will reach exactly the opposite point A on the other bank. It is given that the swimmer reaches the exact opposite point A on the other bank. That means in this case, the swimmer moves along the minimum distance path. So this problem comes under the special case 2. Let alpha denote the angle which velocity V bar makes with the width OA of the river. Here V bar is the velocity of the swimmer relative to water. That means the man begins to swim at an angle alpha with the width OA. But he will reach the exactly opposite point A on the other bank. That means the resultant of V bar and U bar is directed towards the opposite point. VR bar represents the resultant of V bar and U bar. So that is directed along the width OA of the river. So if construct a parallelogram by representing the two vectors U bar and V bar graphically by the adjacent sides of the parallelogram. Such the tail of U bar is attached to tail of V bar. Then the diagonal of the parallelogram represents the resultant of V bar and U bar. That means VR bar represents the resultant velocity of swimmer, or you can say VR bar is the velocity with which the swimmer moves with respect to station or observe one of the banks. The swimmer moves along the minimum distance path and reaches the exactly opposite point on the other bank. So here the angle between V bar and U bar 90 degrees plus alpha. You are given that the man swims at an angle of 120 degrees with the direction of the water flow. That means this angle is given to be 120 degrees. Therefore, alpha equal to 120 degrees minus 90 degrees or 30 degrees. You can have a right angle triangle here. The length of the side opposite to the angle alpha gives you U bar. Length of the side, length of the hypotenuse side gives you V, and length of the side opposite to U gives you U, and length of the side adjacent to the angle alpha gives you VR. So from the figure you can observe sin alpha equal to U by V, or you get U equal to V sin alpha. Here V equal to 0.5 meter per second and alpha is 30 degrees. So sin 30 degrees you can substitute 1 by 2. So you get the answer as 0.25 meter per second. This problem was originally given one of the previous MSET examination. So those who want to copy the solution of the problem, they can take a pause and copy the solution of this problem. So look at the problem 10. That is also linked to the previous problem. In the previous question, suppose if the width of the river is 100 into root 3 meter, then what is the time taken to cross the river? If you want to try it yourself, you can try it yourself. You can take a pause and try this problem yourself. Otherwise, look at the solution of the problem. So, this problem 10 is linked to the previous problem which I have just discussed now before this. The same solution which I have discussed before this. The width of the river is given to be D is 100 root 3 meter. The width of the river I have denoted by capital D in the earlier discussion. That is given to 100 into root 3 meter. You are asked to find the time taken to cross the river. In case you remember the conclusion I have given, in case 2 you can directly use this conclusion to find the time taken to cross the river along the minimum distance path, which is given by T equal to D by root of V square minus U square. Otherwise, you can see the same figure. From this figure, you can write cos alpha equal to VR by V. VR means magnitude of the resultant velocity, that can be written as V cos alpha. Here V is given to 0.5 meter per second. Cos alpha means it is cos 30 degrees. So that can be written as 0.5 into root 3 by 2 meter per second. So actual distance covered by the swimmer while crossing the river can be written as equal to magnitude of the resultant velocity into time taken. So in this case, the swimmer moves along the minimum distance path from O to A, along the line OA. Therefore, actual distance covered is same as the width of the river, which you can write magnitude of the resultant velocity into time taken. Therefore, the time taken to cross the river, you can write width of the river by magnitude of the resultant velocity. Width of the river is 100 into root 3 meter. Magnitude of the resultant velocity is 0.5 into root 3 by 2 meter per second. Simplify this, get the answer as 400 seconds. So answer for the problem number 10 is 400 seconds. You can also solve this problem by directly using the derived result I have discussed earlier. That is the time taken by the swimmer or boat to cross the river along the minimum distance path is given by T equal D by root of V square minus U square. You can use that and solve this problem. You get the same answer even by that same method. Next, I would like to discuss some special cases in resultant velocity with parallel uniform velocities. That means I would like to specifically discuss two cases where the two velocities are parallel to each other. There are some problems in different books based on these two cases. First, I would like to show you the conclusion of each case. Then I will show you the explanation part or mathematical proof for the conclusion. If a man standing on a moving escalator reaches the top floor in time t1 and t2 is the time taken to walk up the same distance when the escalator is at rest, then the time taken when the man walks up in the same direction while escalator is moving is given by T3 equal to T1 T2 by T1 plus T2. Would like to show the calculation for this. Let V1 be the magnitude of velocity with which escalator moves. So in the first case, when the man is at rest with respect to escalator, I mean man moves along with escalator with the same velocity V1 with which escalator is moving. You can write S equal to V1 into T1. Should be T1 there. You can write it in your notebook. Those who want to copy the solution, calculation, they can copy. When the escalator is at rest, let us suppose the man walks up the same distance with velocity of magnitude V2 in time T2. So in second case, you can write S equal to V2 T2. The third case, the man walks up in the same direction while the escalator is moving. That means both the velocities V1 bar and V2 bar are in the same direction. Therefore, magnitude of the resultant velocity of the man means magnitude of the velocity with which the man moves up the escalator with respect to station observed on the ground will be V1 plus V2. Let T3 be the time taken by the man for the same distance. The man walks up in the same direction when the escalator is moving. So you can write magnitude of the displacement is equal to magnitude of the resultant velocity into time taken. That is S equal to V1 plus V2 into T3. So you can substitute the value of V1 from first equation and substitute the value of V2 from second equation in the last equation here. So from first equation you can write V1 equal to S by T1. From second equation V2 equal to S by T2. Those who want to copy the calculation, they can take a pause and copy this calculation. So substituting V1 equal to S by T1 and V2 equal to S by T2. You get S equal to S by T1 plus S by T2 whole multiplied by T3. Then you can divide this equation with S and try to simplify it yourself. You get T3 equal to T1 T2 by T1 plus T2. So anybody, in case you are interested to copy the calculation, you can take a pause and copy the calculation. Then you see the another case, case 2. If a launch or motorboat travels downstream from a position capital P to another position capital Q in time T1 and it travels back from Q to P in time T2, then the time taken to travel the same distance downstream when the engine is cut off is given by T equal to T1, T2y, T2 minus T1. Or you can say time taken by a floating body to move from P to Q is given by T equal to T1, T2y, T2 minus T1. Here T1 is the time taken to travel the distance from P to Q downstream, and T2 is the time taken to travel the same distance upstream from Q to P. T is the time taken to travel the same distance downstream when the engine is cut off. Or you can say T is the time taken by a floating body to move between the two positions. I'd like to show you the calculation for this. Let S be the distance from P to Q. Let V be the speed of boat in still water or speed of boat relative to water. And U is equal to speed of water. In general, we can write magnitude of the displacement is equal to magnitude of the resultant velocity into time taken. That is, when the body moves with uniform velocity, magnitude of the displacement equal to magnitude of the velocity to time interval. So in the first case, of course, in general, we can write magnitude of the resultant velocity equal to S by T. In the first case, when the boat travels downstream, both V bar and U bar will be in the same direction. Then magnitude of the resultant velocity, VR, can be written as V plus U. And time taken is T1. So I can write V plus U equal to S by T1. The second case, that is when the boat travels back from Q to P, it moves upstream. Upstream means the direction of the motion of the boat is opposite to the flow of river water. So in the first case, the boat is said to be moving downstream when the direction of the motion of the boat in the direction of the velocity of river water. In the second case, the boat is moving upstream, means direction of the motion of the boat is opposite to the direction of the velocity of the river water. So in the second case, magnitude of the resultant velocity is V minus U and time taken is T2. The third case, that is to find the time taken to travel same distance downstream by a floating body. You have to find the value of U, because a floating body travels with the speed of water. Or even when the engine of the launch is cut off, the launch moves like a floating body in the direction of flow of water with the same speed equal to that of water. Of course, in the present discussion, it is assumed that all the velocities in each case are uniform. So to find the time taken by the floating body to travel same distance, we have to find the value of U in terms of T1 and T2 from the first two equations. For that, we have to eliminate V from these two equations. So subtracting the second equation from first, you get the value of U. So when the engine is cut off, you can write U equal to S by T. When the engine is cut off, the launch moves with the speed of water in the direction of flow of water and travels same distance as from P to Q, let us suppose in time T. From first and second equations, you can write V plus U minus of V minus U is equal to S by T1 minus S by T2. Or you get 2U equal to S into 1 by T1 minus 1 by T2. You can substitute. From third equation, you can write U equal to S by T. You can substitute U equal to S by T on the left hand side. Come and simplify it yourself. Solve for the time T in terms of T1 and T2. You can substitute U equal to S by T here on the left side. You get this equation. You can simplify this, you get the result I have given in the beginning. In case you are interested to copy the solution, you can take a pause and copy the solution. You get T equal to T1 T2 by T2 minus T1. Next, I would like to discuss about the direction cosines of vector. Earlier, I have discussed how a vector can be expressed in terms of its rectangular components and unit vectors along the 3 coordinate axes. So just look at the screen here. Let us suppose a vector A bar makes an angle alpha with the line parallel to the positive direction of x-axis. That means in the diagram I am showing the plane which contains the vector A bar and the line parallel to the direction of positive x-axis. So in the figure I am showing the plane which contains the vector A bar and the line which is parallel to the positive direction of x-axis. Let us suppose the vector A bar makes an angle alpha with the positive direction of x-axis. As I discussed earlier, the vector A bar lies in the xy plane. Then we can write A bar in the form I cap into AX plus J cap into AY. AX and AY are the rectangular components of the vector A bar along x and y axis. So in 3-dimensional space, vector A bar in general can be written in the form I cap into AX plus J cap into AY plus K cap into AZ. Here AZ is a rectangular component along Z axis. K cap is unit vector along Z axis. So in the figure on the left side, I have shown the diagram, the plane which contains the vector A bar and the line parallel to x-axis. So this will give you AX. That means AX represents projection of the vector A bar on x-axis, or AX is a component of vector A bar on x-axis. So from this figure you can write cos alpha equal to AX by magnitude of vector A bar. Similarly, beta is the angle made by the vector A bar with the positive direction of y-axis. You can write cos beta equal to AY by magnitude of vector A bar. Here beta is the angle made by vector A bar with the positive axis. Then we can write cos beta equal to AY by mod of A bar. The same way, if gamma is the angle made by vector A bar with Z axis, then you can write cos gamma equal to AZ by magnitude of vector A bar. Would like to discuss the relationship between the 3 direction cosines of the vector. We know that magnitude of vector A bar is root of AX square plus AY square plus AZ square. Or you can write square of the magnitude of vector A bar equal to AX square plus AY square plus AZ square. If you divide both sides of this equation with square of the magnitude of vector A bar, you get square of magnitude of A bar by square of magnitude of A bar equal to AX by mod of A bar square plus AY by mod of A bar square plus AZ by magnitude of vector A bar square. So if alpha is the angle made by the vector A bar with the positive direction of x-axis, then you can write AX by mod of A bar equal to cos alpha. Similarly, AY by mod of A bar you can write cos beta. AZ by mod of A bar you can write cos gamma. So you get cos square alpha plus cos square beta plus cos square gamma equal to 1. That means sum of the squares of the three directional cosines of the vector is always equal to 1. This cos alpha is usually denoted by L in most of the textbooks, and this cos beta is denoted by small m. This cos gamma is denoted by small n. So this relation you can write L square plus m square plus n square equal to 1. Or you can write cos square alpha plus cos square beta plus cos square gamma equal to 1. So sum of the squares of the three direction cosines of any vector is unity. You can express the unit vector in the direction of vector A bar in terms of the three directional cosines of the vector A bar. So if A bar is a vector, then the unit vector in the direction of vector A bar is denoted by this symbol. We read it as A cap given by A bar by magnitude of vector A bar. You can write A bar can be written as I cap into AX plus J cap into AY plus K cap into AZ. So you can write A cap equal to I cap into AX by mod of A bar plus J cap into AY by mod of A bar plus K cap into AZ by magnitude of vector A bar. As I discussed previously, if alpha is the angle made by the vector A bar with the positive direction of x-axis, then AX by mod of A bar will be equal to cos alpha. If beta is the angle made by the vector A bar with the positive direction of y-axis, then AY by modulus of vector A bar will be equal to cos beta. If gamma is the angle made by the vector A bar with the positive direction of z-axis, then AZ by modulus of vector A bar can be written as cos gamma. Therefore, unit vector in the direction of vector A bar can be written as I cap into cos alpha plus J cap into cos beta plus K cap into cos gamma. So if you are given the three directional cosines of the vector or the angles made by the vector with the three coordinate axes, then you can find the unit vector in the direction of the given vector. Now from this equation you can write modulus of A cap. In general, modulus of vector is equal to sum of the square root of sum of the squares of the coefficients of I cap, j cap, and k cap. That is modulus of vector is equal to sum of square root of sum of the squares of the three rectangular components along the three coordinate axes. But a cap represents a unit vector. That means modulus of vector a cap can be written as equal to 1. Therefore, on the left hand side, I can write 1 equal to root of cos square alpha plus cos square beta plus cos square gamma. That means the same conclusion which I discussed earlier is again we have arrived. That is cos square alpha plus cos square beta plus cos square gamma equal to 1. Next, I would like to show you the PowerPoint for the same discussion. So in case you are interested to write the notes for the directional cosines of vector, you can copy from the PowerPoint. So again, I would like to revise the same discussion, directional cosines of vector. So those who are interested to write the notes for this, they can copy the notes. If alpha, comma, beta and gamma are the angles made by vector A bar, again repeat, if alpha, comma, beta and gamma are the angles made by vector A bar equal I cap into Ax plus J cap into Ay plus K cap into Az with X, comma, Y and Z axis respectively, then cos alpha, cos beta and cos gamma are called as the direction cosines of vector A bar. We can write L equal to cos alpha, Ax by mod of A bar, small m equal to cos beta, that is equal to Ay by mod of A bar, small n equal to cos gamma, which is equal to Az by mag of A bar. The relation between the three directional cosines of the vector is L square plus M square plus N square equal to 1. So those who want to copy the notes, they can take a pause and copy this part. So our cos square alpha plus cos square beta plus cos square gamma equal to 1. So if L, M, N are the directional cosines of vector A bar, then the unit vectors which have same direction as the vector A bar is given by A bar equal to Li cap plus Mj cap plus Nk cap. That means you can write A cap equal to cos alpha into I cap plus cos beta into J cap plus cos gamma into K cap. There is one problem here. Please look at this problem. A vector A bar makes angles 30 degrees and 120 degrees with Y and Z axis respectively. Find unit vector in the direction of A bar. You want to try this problem yourself first, you can first try it yourself. You can take a pause and try the problem. Then you can look at the solution of the problem. So it's given that the angle made by the vector A bar with Y axis is 30 degrees. The angle made by the vector A bar with Z axis is 120 degrees. That means beta is 30 degrees and gamma is 120 degrees. You're asked to find the unit vector in the direction of the vector A bar. That means you have to find A cap. For that you have to find the three directional cosines of vector. So cos beta, which you write it as M, equal to cos 30 degrees equal to root 3 by 2. Cos gamma, which you write as small n, cos 120 degrees, that is equal to minus half. And you have the relation between the three directional cosines, L square plus M square plus N square equal to 1. You're not given the value of L here. Can substitute M equal to root 3 by 2, N equal to minus 1 by 2. So you can simplify this. So you get L square equal to 0 or L equal to 0. So unit vector in the direction of the vector A bar is given by A cap equal to I cap into cos alpha plus J cap into cos beta plus K cap into cos gamma. Or you can write A cap equal to L I cap plus M J cap plus 0 K cap. Here L is 0, M equal to root 3 by 2 and N equal to here N equal to minus half. So you can write the answer as A cap equal to half of root 3 J cap minus K cap. This is the answer for the problem. Those who want to copy the solution of the problem, they can take a pause and copy the solution of this problem. So, with this we have completed the discussion of subtraction of vectors and addition and subtraction of vectors. So then I am giving some multiple choice questions after this problem.